Hello, this is Renaud Angeran from SynControl. In this video I'm going to explain how to read and how to use the AQL tables that are used for random inspections, meaning inspections of products, product batches based on random sampling. I've been in this industry for more than 10 years. We've even developed our software to manage all these statistical calculations. So, the first thing to understand is that this is to be used when the inspector takes only a sample out of the total population. Okay, doing a 100% inspection of all the pieces in the batch can take a long time, or if you need to do certain tests, it might destroy the samples. So it's really not something you can do in a lot of cases. So the question becomes how many samples to check. You can follow certain statistics that I'm going to explain in this video, rather than simply saying we'll check 10% or 20% or 5%, which in the end doesn't help so much because it doesn't give you the limits on the number of defects for acceptance of the whole batch. So the widely used settings for the ISO 2859-1 standard is normal severity and level 2. We'll go over that. Okay, the central concept that a lot of people in the trade have heard of is the AQL, Acceptance Quality Limit. And most people don't actually really understand what it means and how to use it. And that's what I'm going to focus on in this video. First, the buyer and the supplier, both sides should agree on the AQL limits. Okay, what should the limit be on the number of defects for each batch? Okay. There are some widely used settings for consumer goods in China and a lot of other countries also, based on 3 categories of defects: critical, major, minor. When usually these are the numbers 0, 1.5 or 2.5 and 4. Some buyers might add maybe like catastrophic here, or maybe incidental here, might reduce the number or increase the number of defects, of categories of defects. This is not in the standard, so it's really up to you as the buyer. Let's take an example. Let's say you buy 40,000 pieces of memory sticks, like thumb drives. Okay, they're going to be made in one batch by a supplier. You're going to go with single sampling plan, normal severity, level 2, which is most of the time what is done. And you're going to go with these AQL limits. Now, let's go step by step. First, the AQL tables will give you the code letter. So 40,000 pieces is in this range, and you go with level 2, which is used most of the time by default. Even the standard says that by default, usually this is the one to go with. Okay, so the letter is N. Now, what do you do with N? The next step is you go to the next table, which will give you the sample size and the AQL limits. So the next one, for normal inspection, the next table looks like this. So N means you need to check 500 pieces. Now, what about the number of defects? That is the maximum, the limit that can be accepted. If you say for critical defect 0, okay, the limit is always going to be 0 anyway. If you say 1.5 for major defect and 4.0 for minor defects, well, this means here, there's an acceptance number and a rejection number. You see ACRE. So acceptance is 14 and rejection is 15, meaning that if in your inspection you find 15 or more major defect, it's failed. If on the minor defect, if you find 22 or more, it is failed. That's what it means. Okay. Just a note about this arrow, you could say that for minor defects you only check 315 pieces, that's what it means, and then this would be the limit. Or you can just say, I'm going to check 500 pieces for critical, major and minor defects all together on the same number of samples. That works too. See, by default it says use the first sampling plan above the arrow, which means 315 for the minor defects. However, the standard also says this, which means it's really up to you. And in a lot of cases, the inspector would just check all types of defects on that sampling size and would just go with 21, 22, which is the same numbers as here, and that works fine also. Okay, to conclude, what does it mean for your sampling plan? Code letter is N, you draw 500 pieces, the limits are 0 critical defect allowed, no more than 14 major, no more than 21 minor. Okay, for example, if you find 17 major, it's failed, even though you found no critical defect and you're way below the limit here. This is failed. If you find these numbers, which are just above the limit, okay, it's accepted. That's the way it works. It's not very complicated. So all of this was for single sampling plans. Now let's look at double sampling plans. Now what does this mean, double sampling plans? It means there are 2 steps. The inspector has to go through 2 steps when taking the samples and then checking and counting the defects. Okay, let's take an example. For simplicity, let's just say there are major defects only, which some buyers sometimes prefer to do, and with the same code letter as before. So we are still here with the N. This is unchanged. And then for double sampling plans, we're still in normal inspection. This is the way it works. So your AQL is 1.5 for major defects. And here for N, you actually have 2 numbers to check. So first sampling 315, second sampling 315, right? And for each one, you have a number of defects as a limit. Now let's look at it a little bit more close up. So first one, 315, what does it mean? It means that you first pick 315 samples. Then either it's very good, meaning 7 defects or fewer, it's accepted. Or it's very bad, meaning 11 defects or more found, then it's rejected. Already no need to go to second step. But if you find 8, 9 or 10, it's not clear, okay? You only took 315 samples, and in the single sampling plan you would have taken 500 samples. So you're really trying to find a conclusion based on a small sample. And there's a case, 8, 9 or 10 defects, where you need to pick another 315 samples, and then the limits, now you add up all the number of samples from the first and the second sampling that you did, and if it's 18 or less, it's accepted. If it's 19 or more, it's rejected. And then at that point, you've picked 630 samples, and you can make a decision with a higher confidence. In summary, okay, this is exactly what I said before. That's the way it works. It's not that complicated, but it's very seldom used based on what I saw. Now, let's look at all the implications of random sampling. Random sampling, again, means you're picking a certain number of samples at random from a total population, which typically is a batch of products. Can be a batch of finished products, can be a batch of parts, semi-finished products, and so on. Now, if the whole population is good quality and you accept it, it's good, it's fine. If it's bad quality and you reject it, good. But since you work on random sampling, things are not that simple, and there's always a risk that you accept bad quality or you reject good quality, right? And you can't really get rid of these risks unless you check 100% of the goods. So these 2 risks have a certain name, and this one obviously is the supplier's risk. It's good quality but is rejected. Well, no luck for the supplier. And then you have the converse, the buyer's risk, that it's bad quality but it's accepted, and then you have to accept it from the supplier, you have to pay them, you have to try to use it, do something with it if possible, okay? And they're called alpha risk or beta risk. Now the whole question is how to balance or how to distribute these risks of errors, because again you can't really avoid them when you do random sampling. Okay, there's a fundamental concept here, the OC curve, operating characteristic curve. And okay, ideally, if let's say your limit is 2.5%, I don't want more than 2.5% of defect in a batch, it would look like this: 100% certainty that it will be accepted if it's under the limit, and then 0% probability of acceptance if it's above the limit. That would be perfect. You get 2% for sure it's here, you get 3% for sure it's rejected. Okay. Unfortunately, this is possible only if you check 100% of the goods and if your measurements are perfectly done and on and on and on. Okay. Now, if you go with random sampling, this is an OC curve, operating characteristic curve, and the way it works again is the same idea. You have 80% chance of accepting a batch that has 2% of quality, all right, of defects, I mean. Okay. Now, it's not exactly the same as your ideal plan. Let's say it this way. Okay, here there's a lot of things that are not really good, and here there's a lot of things also. Okay, but statistics help us get as close as possible to it, while still being very efficient and only checking a small proportion of the whole population. So, what is this? This is the alpha risk. What is this? This is the beta risk, okay? Buyer's risk of accepting something bad, supplier's risk of rejecting something good. Now, the standard set beta at twice the value of alpha. Okay, you can see it here, meaning that the supplier's risk is lower than the buyer's risk, and this means it's more favorable to the supplier. Okay, let's look at it another way. Even if you set an AQL of 1%, you might accept a higher proportion of defects. Actually, the standard even includes this. Let's say your AQL limit is 1.0, meaning you don't want more than 1% of defects in the batch. And let's say you go with an inspection of 200 pieces. Well, you might accept a batch with up to 4.59% of defects, up to 10% of the time. Okay, so again, this is why we say it's more favorable to the supplier, and the basic logic is that this standard is to be used for very regular production batches, and you don't want to reject a batch. You don't want to have a high chance of rejecting a batch if it's a long-term relationship and they keep producing the same products and so on. It's assumed that quality is okay. All right, that's the general concept. Let's also understand why there's an apparent paradox. Okay, here you say 1.5%, right? This is in non-conformity per 100 items, so it means 1.5%. And 1.5% of 500 is not 14, right? It's 7.5. Why? Well, again, because the standard is more favorable to the supplier. Okay. Now, there's something that comes up from time to time. It's the concept of acceptance on zero. What does it mean? It means that the buyer says, as soon as I find one defect, the whole thing is rejected. It's relatively frequent in the auto industry and in some other verticals where the buyer can really not tolerate many defects, okay? And they protect the buyer much more. Now, typically it looks like this. So the alpha risk is huge and the beta risk is much smaller. So it's really the opposite. The problem with this is, that very few suppliers in China, if you buy, let's say, general consumer goods, or even a lot of mechanical or industrial products, would not accept that. To be negotiated, let's say. It's a tough sell. In summary, you can use the statistics in the AQL tables if you want to find some widespread defects. But don't fool yourself. If you say the AQL is 1%, it doesn't mean any batch with more than 1% of defect would be rejected. That's not the way it works, not 100% of the time anyway. Okay? And really the most important again and again and again is that you work with good manufacturers. I'm sure you heard that before, but you need to qualify the manufacturer, do some factory audits to check their capability. You need to ensure their first pass yield, and on and on and on. There's a lot of things that can be done before it goes into the inspections. Okay, now when to use this standard, I touched on this a little bit already, but let's go through it in detail. First, it's only for inspections by attributes, meaning you can say if a product is good or bad. Okay, conforms, does not conform, very clear. If it's continuous data, 1.7, 2.3 and so on, this is not going to work. There are some other standards that can be used, but don't use this one. It's for lot by lot inspection, meaning a continuing series of lots of the same product or the same part. All right, so it's for the case where a supplier, a producer ship batches regularly to the same customer, okay, the same product. If you do some one-shot orders to a new supplier, never made this product before, never sent it to you before, and so on, this is not really applicable. Okay, most people still use it, but be aware that by default the plan assumes that quality is okay, and it means the buyer's risk is higher than the supplier's risk. Right? Also, there are some other plans. If you really want to use the right plan for your situation, maybe because you cannot use the ISO 2859-1 standard, there are some other plans. The main issue is if you purchase products from suppliers that are used to AQL types of inspections, it's going to be a tough sell to explain to them to use another plan that they are not familiar with. Okay, with totally different things. It's not going to be about AQLs, it's going to be about LQ. Do you really want to teach them how to use this? It's unfortunately most of the time it's just not very realistic. Okay. Now, I touched on this a little bit before. Will you catch all the issues? Clearly the response is no. I touched on this before. Even with an AQL of 1, about 10% of the time you might accept a batch with up to 4.5 or 4.6% of defects, simply because the statistics are more favorable to the supplier. All right. So the probability that the batch is accepted but there are too many defects is not negligible. All right. Something that very few people use is the switching rules. Actually, it's quite an important part of the standard. That was the reason for a lot of the updates in the military standard when that standard was still managed by the US Army. So more than 95% of inspections are performed in normal severity, and that kind of makes sense, but you are missing on a lot of the subtlety of the standard. All right, so this is straight from the standard. Basically the starting point is here. You go for normal inspection. If they get a good score, you go down to reduced inspection, and you only need to pick fewer samples. Okay, now something bad goes on, you go back to normal inspection. If you're here and then there's several failures, you go to tighten inspection. Doesn't necessarily mean more samples to check, but it means the limits are going to be a bit tighter. Okay, you know it's risky, you want to take less chances. Okay, and then if it keeps going bad, then don't go for inspection, or maybe go for 100% inspection. Maybe just change the supplier. Something is just not working. All right. Again, either you stop the relationship if really they keep failing, or maybe send some process engineers, send some quality auditors, maybe to understand why. Okay, I talked before about the double plan. Okay, I showed you how to use the AQL table for simple plan, and then I showed you again about the double plan. Now, what is the advantage of using a double plan rather than a simple plan? Double plans on average require you to check fewer samples, okay? And it's pretty easy for an inspector to say, well, you know, I found 9 samples, but between 7 and 11, I have to go deeper. So let me keep working on it. The supplier side, we usually not try to put a lot of pressure on the supplier. It's, you know, it makes a lot of sense to say, okay, you want to go deeper, just go deeper, if that's what the plan calls for. Okay, so that there's less pressure here. And then by the time the inspector has checked a lot more samples, usually the number of defects found is usually way below or way above the limit anyway. So there's less pressure on, you know, just that don't count this one sample so that it passes. Okay, that's an important one. There's also some other plans, I'm not going into this, that are even more efficient. So on average, number of samples to check with a simple plan is constant, whatever the proportion of defects. Okay, and again, these are average values, but let's say your AQL is here, and if the proportion of defects is pretty close to the AQL, it is still going to be lower than the number of samples to check in a single plan, but it's still going to be on average lower. If it's very clearly good or very clearly bad, then the difference is even greater, and inspection can be done much faster. Okay, the sample shows several examples here with different parameters. Is the same idea. And then if you have a sequential plan, a multiple plan, yeah, is even better than just double. And if you go with sequential, it's even a little bit more efficient. Okay, but the one downside of using a double plan is that the inspector might say, well, I just checked my 315 samples. I found 8 defects. If I found just 7, I can just stop now and go back home. So, well, let me check the defects again. Maybe this one can be downgraded or just ignored. Okay, I finished my job, I go back home. That's an issue. And also, if you subcontract inspections to another firm and you tell them to use a double sampling plan, they don't really know how much time to quote to you, because it will depend on the number of defects. So either you are open to just trusting them and saying, okay, if you need 1 Monday, we'll pay you 1 Monday. If you need 2 Mondays, we'll pay you 2 Mondays, or whatever. If it's 6 hours, we'll pay you for that. If it's up to 10 hours, we'll pay you for that. So basically, you trust them and at the risk of being overcharged. Or if you want a solid quotation that will not change, then you have to go for a single plan or negotiate some kind of special deal, special setup with them. All right. So I hope I covered all the points that you wanted to hear about in this video. And if you have any questions, please contact me. This is on my website, this is my blog. This is also a blog on our software company. You will find a way to contact me. You will also find a lot more content